students, in this video we will learn about transformation of functions part 1, that is section 2.6 of your book. So transformation of functions in the sense, given a function, so how do you move the function without altering the way the function looks? So you do that by changing the values of the output or the values of the input. That is how you do it. Like you are shifting the whole function from one coordinate to another, or changing the position of the function. So that is along y-axis or along x-axis. So that is what you learn in this video. That is nothing but transformation of functions. So the first transformation would be vertical shifts. So when can you shift a graph vertically? That is, you are moving the graph along the y-axis. So if you are moving on the positive side, or if you are moving the graph above the original graph, so that means you have to add a specific value to all the functional values, right? So in the same way, if you are moving the graph below the origin and along the y-axis, so that is towards the negative side or below the original graph, you have to subtract some value, some constant value with all the functional values of the given function. So that is nothing but the vertical shifts. So vertical shift happens if you alter the functional values. So let us define vertical shifts of graphs now. Vertical shifts of graphs. Suppose C is greater than 0. So y is equal to f of x is the given function. So if you add c to it, that means you are moving the graph, or you are shifting the graph upwards, that is above the original graph. So this shifts the graph of y is equal to f of x upwards. So the shift would be upwards c units. So similarly, if you have to shift the graph below the original graph, that would be you have to subtract c from the original graph. That would be y is equal to f of x minus c, and this particular operation that you do with the original graph f of x will shift the graph of y is equal to f of x downwards c units. So all the functional values, so you can see that you are shifting all the functional values by c units, whether it is above or below. So that means the original form of the graph, or the way the graph looks like, will not change. You are just changing the position of the graph. That is, you can see the thing that is below. I have drawn two graphs. If the original graph is the one that I have drawn in blue, f of x, so the one that is red would be f of x plus c. Okay, so and the same thing applies to the picture that is next to it. If the original graph is in blue, so the one that is below, the graph has been shifted below the original graph. So that vertical shift, there is happening a vertical shift is happening to the original graph. Therefore that means, and that is below the original graph, therefore you are subtracting a value c from all the functional values of the original graph. So if you are asked to do the transformation given a particular function, so I will do an exercise problem. So an exercise problem which states that sketch the graph of the function. You should not plot the points, but by starting with the graph of a standard function and applying the transformation. So I will solve number 30 for you. So the given function is f of x is equal to x square minus 4. So you have to choose the original function for which you can treat the given function as a shift. So I will choose the original function to be x square. So I already have formulated the values of f prime. I will consider or name x square as f prime of x. So I have formulated values of f prime of x is equal to x square. And what I will do, I should not the instruction says very clearly that you should plot or sketch the graph not by plotting points. That means that you should not consider the given function and calculate the values of the functional values and plot it. You should use the original function values and do the shifting process. So that I will be doing by subtracting -4 of all the functional values given in this table. So 0 minus -4 would be -4, 1 minus -4 would be -3, 4 minus -4 is 0, 9 minus -4 is 5, 1 minus -4 is, the values repeat. So it would be 4, -4, 3, okay, sorry, 1, it was 1. So 1 minus, so that is -3, 0 and 5. Correct? So now you can use the values that I formulated. I did not compute the values using the given graph, but I computed the values by using a function f prime of x is equal to x square. So that is what I am doing here. So now if I plot the graph, I will be getting 0, -4. So that would be here. Okay, so all the values I will shift 4 units below. So the original point is here. So if I consider 4 units below, 1, 2, 3, 4, the next value will be here. Okay, then 1, 2, 3, 4, so another value is here. So 1, 2, 3, 4, this value is here, and 1, 2, 3, 4, it's here, 1, 2, 3, 4, it's here, 1, 2, 3, 4, it's here. So the one that I have marked in blue, I have just shifted all the values of the red points, so the points in the red, to 4 units below the original graph, because the given graph has a negative, that means has a constant being subtracted from the original graph. Therefore I shift all the points of x square below 4 units. So now if I join the points in blue, so you can see the shape of the graph is not changing, but it is below the original graph. That means it is there is a vertical shift happening below the original graph. Therefore that matches to the explanation or the definition that we gave that I gave right now. That is, if you subtract a constant greater than 0 from the original graph, there will be a vertical shift downwards. So we will do the same. We will move further, define another kind of shift, that is horizontal shifting. So that means the name suggests that the shifting is happening horizontally. That means along x-axis, right? So if you are changing the graph, or if you are shifting the graph along x-axis, it means that you are changing the input values by some constant. So if you are shifting a graph along y-axis, that was a vertical shift. There you were operating on the functional values, that is the output values. But if you are shifting a function horizontally, you will be operating on the input values, that is the x-axis values, that is x values of x. And that happens before you calculate the functional values. So you will shift the input values, then you will calculate the functional values accordingly, and you can see that the graph when plotted after doing the shifting process. So you can see that the graph shifts either towards right or towards left of the original graph. So let us define the horizontal shifts of graphs. Suppose C is greater than 0 and to graph y is equal to f of x minus c, shift the graph of y is equal to f of x to the right by c units. So the same thing applies to that means when you subtract a constant greater than 0 for the input values, that means you are reducing the values of the given input values. That means you are moving towards the left of the x values. So when you are adding a constant, you are increasing the values of the inputs. Therefore you will be moving on the right of the given values. So okay, to graph y is equal to f of x plus c, shift the graph of y is equal to f of x to the left c units. Okay, let us see what is happening here. So I will take two graphs. So I will be needing two coordinate planes. Okay, this is y-axis, x-axis 0, x-axis, y-axis and 0. So suppose I have an original graph that looks like this. Okay, so this is f of x, right? So the same thing applies here also. Okay, f of x minus c would be a shift in the right of the graph. That would be here. This is f of x minus c by definition, and if you move towards left, you will have to add c to the function. So that would be here. The red one is a horizontal shift of the given graph. So this is f of x plus c. I'm sorry. So that would be f of x plus c. Okay, and this is f of x, original function. And the difference between these two functional values is c, or sorry, x values, input values is c. Okay, let's do an example of horizontal shift now. That would be problem number 36 in your book. So problem number 36 states that f of x is equal to square root of x minus 4. So you have to the same instruction follows even here, that is, sketch the graph of the function not by plotting points but by starting with the graph of a standard function and applying transformations. So the standard function that I will consider is f prime of x to be square root of x. So if I use a graphing calculator, I will use a graphing calculator. So that would be y is equal to square root of x. So this is the green color graph is the original graph. So if I consider the shift y is equal to square root of x minus 4, so you can see there is a shift of the graph towards the right, correct? So that means you are subtracting a constant, and the graph is subtracting a constant from all the input values, and the graph is shifting towards the right. The green one is the original one, and there is a shift by 4 units of the original graph. So how do you do that? Using like as the instruction suggests, by considering the graph of a standard function. So first consider root of x, square root of x, and plot it, and then what you do, just move towards the, like, consider all the x values and subtract minus 4 of the x values, or shift negative 4, that is 4 units towards the right of each of the input value that you consider. So that will be your square root of x minus 4. Okay, so if I move further, this would be the thing about horizontal shifting. So let us move further with reflecting graphs. So reflecting graphs, in the sense, if you have a graph in one coordinate plane, in one quadrant. So if you have the graph in the opposite quadrant, so what does it take to have a reflection of the graph? That is, if you have it on the maybe say above x-axis, and if you have another graph below x-axis, that would be considered as a reflection. So, and if you have towards the right side of a graph, the original graph is on the right side of the y-axis, and if you have the reflection on the, if you have an other graph which is similar to the shape of the given graph on the left side of y-axis, that would be a reflection. So what does it take to reflect it? That is, move from one side of x-axis to the other side. And what does it take to move the graph from one side of y-axis to the other side? So what does it take to create reflecting graphs? We shall see that. So by definition, reflecting graphs, so that would be to graph. So if you have the original graph in the above x-axis, so that means the reflection would be below x-axis. So what does it take to change it? You have to operate all the functional values by negative sign. The same thing applies to a graph which is below x-axis. If you have to change it or reflect it back above x-axis, you will operate it by negative sign for all the functional values. So to graph y is equal to negative f of x, reflect the graph of y is equal to f of x in the y-axis, in the x-axis. So the reflection, what is the thing that is between this process? That would be the x-axis. So it would be above or below x-axis. Therefore the reflection is happening over the x-axis. So the same thing applies to y-axis. To graph y is equal to f of negative x, it is same as reflect the graph of y is equal to f of x in the y-axis. So you can observe that a reflection in the x-axis is same as a vertical shift, but it is like the shift crossing the x-axis. correct? And the reflection of y is equal to f of x in the y-axis is same as the horizontal shift, but the horizontal shift happens crossing the y-axis given an original graph. So let us do this exercise the same way that we did for the horizontal shift and the vertical shift. I will do one kind, that is reflection of the original graph in the x-axis. I will give you the other form as a quiz in the part 3 video. There are no quiz questions in this video, so I'll give all the quiz questions together, combining part 1, part 2, as well as part 3 in part 3 at the end of part 3 video. So that would be, I will do one problem for you, that is number 38 in your exercise. That would be f of x is equal to negative of modulus of x. So let us I will use the graphing calculator, because you know that you have used the table of values for plotting absolute value of x and all. Okay, so this is absolute value of x, the red one. I will plot y is equal to negative, that is the given graph, negative of absolute value of x. So you can see the original graph, that was the graph in green, so that is above x-axis, and the graph in orange is below x-axis, so it is a reflection. So this is f of x is equal to absolute value of x, and this is f prime of x, or this was f prime and this is f. Okay, f of x is equal to negative absolute value of x. So you just follow the condition, that is formulate the values of f of x is equal to absolute value of x, plot the graph, and keep shifting the values below the x-axis. So keep shifting it below the x-axis. So this can be considered as a reverse vertical shift, that is you are reversing the way the graph looks and plotting it below the axis. So the red line will be looks like a V, and the orange graph looks like an inverted V, so the mirror image. So that is what reflection does to the graphs. Okay, hope you understood the process of transforming functions using vertical shift, horizontal shift, and reflection. I will give all the quiz questions together of this chapter at the end of the last video. In the next video, you will learn about vertical stretching and shrinking of a graph. So how do you stretch and shrink a graph? So that is also a kind of a transformation. So you will learn that in the next video. Thank you.